This video is about using Pygame to build a snake game from scratch, and how to use OpenAI Gym to perform reinforcement learning and train the snake to play the game. What we will cover through this video involves installing packages, coding the game, gym environment logic, and executing learning in Jupyter Notebook. I have plans to make more videos on this topic with different games, so if you are interested, make sure to subscribe. And if there is any game you think it should be in this course, mention it in comments. First thing we should do is to install packages with pip. So let's open command prompt. Pip install pygame is the command to install pygame. I got these packages before, so as you see, it tells me you already installed it. Next, packages are stable baseline tree and gym. Enter pip install stable baseline tree with extra to install both them at once. Next one is Jupyter Notebook. Use pip install notebook to install it. The last package is PyTorch. To install it, go to PyTorch website, the Get Started page. Scroll down and in Start Locally section, choose your preferences. I will use a stable build, Windows, pip and Python. The last one is about using GPU or CPU. If you prefer GPU, use Coda version. Copy the command and run it in command prompt. We are done with installing packages. Let's move to the next part. This part is a quick overview about the snake game. Basic snake games usually designed in grids. Here we are going to make a grid with 40 cells in width and 30 cells in height, and in each side of grid there is a wall. A snake and apple should be generated randomly. Fixed positions for a snake or apple will cause problem in agent training. How? Assume you put apple in right side of the screen and a snake in the left side. This way, a snake thinks it should always go right to find the apple, which is a wrong act. This is the part we code the snake game. At first, we import libraries we need. Those are Pygame and random. Before defining windows, height and width, or rows and columns, let's take a look on how Pygame coordinate system works and how we are making game based on that. In Pygame, if you want to draw a shape into a screen, you must specify top left position of that shape. Top left position of game window is also the 0 point of coordinate system. In this coordinate system, if you move to the right, x increases, and if you go down, y increases, and vice versa. To this point, we know there is 40 cells in a row and 30 cells in a column. If you add one cell as margin to each side and side lengths of a cell be 15 pixels, with a simple math, you can find width and height of the game window. We make row and column variables to control drawing apple and snake. FPS should be low enough to control game speed for human playing. In training, we will have a higher FPS. Here are game variables that we use to control the game. A snake deer for keeping a snake movement direction and changing it. A snake list to store snake part positions. Apple pose to store apple position. A snake eat boolean to determine if apple is eaten or not. A snake dead boolean to know if a snake is dead or not. And a score variable to keep how many apples a snake eats. I will use Pygame init to start Pygame. This should be done before any Pygame use in code. Display set caption to change window name. Here we make a surface and name it display, and from now on we will draw a game object on this surface. Pass width and height as a tuple into set mode. Clock object is for controlling game speed. We will pass FPS into it later. Running is a boolean to end the game while loop in case of game over. We set it as true at the start point and change it to false whenever a snake dies. This while loop is the main part of the game code. Game will run until we end this loop. There is 4 parts we should do it inside this loop, and those are receiving game inputs from player, handling backend of the game, drawing game object into the screen, and controlling game frame rate. To read inputs, we can use Pygame event. With method get, we can get all events such as quit, keyboard key press, mouse motion and clicks, and so on. First thing we need to check is quit. If player decides to close window, this event is activated. So, in this case, we change running into false and break from the for loop. Next thing we do in game loop is updating display. Next line we pass FPS into tick method of clock object. This is a simple game loop. After this loop, we use quit function to close Pygame. Let's run the code and try to close the window. Okay, let's work in draw part and fill screen with a gray color. To do it, we use the fill function that works on surfaces, and it takes a tuple that includes 3 numbers for RGB. After it, we draw 4 borders for each side. Those are our walls and their distance from each side of the window is 15 pixels. To draw them, I use rect function in Pygame draw class. This function takes a surface, color of the rectangle, that here I use a string version instead of RGB tuple, and a tuple. First 2 elements of this tuple are x and y coordinate of top left corner of rectangle, and next 2 elements are width and height of the rectangle. After it, we go to event controlling part and check if there is any key down event in that list. We check for escape and arrow key press. If escape is pressed, we do the same thing we did for quit event. If any arrow key is pressed, we change snake direction to that arrow key direction. Okay, now let's move to the game backend part and make a function to generate a snake and its initial direction at game start moment. Name of this function is snake generating, and we need to pass a snake list and a snake dir into this function. At the start, a snake has 3 parts that we call them head, body and tail. We check if a snake list is empty, and if yes, we make a snake. Every snake part is a list that has x and y coordinate of that part. For head, we are free to choose any cell randomly, but I will choose a cell that is at least 2 cells far from the walls. Because this way, when I randomly choose body and tail part, I will not go beyond the walls. For body part, I will choose a cell randomly from 4 cells adjacent to the head. For tail, it would be a little different. We need to make a list of 4 cells adjacent to body and then remove body cell from that list. Now we can choose a cell randomly from that list. Okay, now we check if a snake direction is empty, and if yes, we choose a valid direction. An invalid direction is the one that makes a snake head go back and collide with its body. First, we make a list from 4 directions and then we compare x and y position of head and body cell to find invalid direction. If head has a greater x than the body, it means head is on the right side of the body, so head can go to the left. With similar logic, we wrote 3 more if statements to remove up, right and down direction from our list when they are invalid. At the end, we choose one direction for a snake randomly from the list. We are done with this function, so we return a snake list and a snake direction that we change. Next function is apple generating. Its job is to make apple at the start of the game and every time a snake eats apple. We pass a snake list and apple pose list into this function. First, we check if apple pose list is empty. If yes, we choose x and y coordinate randomly from first cell in grid to the last one. Then, in a while loop, we check if this coordinate is in a snake list. While yes, we make a new coordinate and we check again. If new coordinate is not in the snake list, we make apple pose list and return it. Now that we are done with these two functions, let's check if they work properly. We need to add these functions at the start of the game loop, and then draw apple and the snake. To draw apple and the snake, we will use rect function. A snake and apple rectangles have 13 pixels side length, and they will be in the center of the cells. Before we draw apple, we check if apple pose list is empty or not. If not, we draw it. We draw a snake head in different color from its body, so when we play, we will be able to recognize a snake head from its tail. Let's reset a snake list and apple pose list in their function, just for now to see if they are generated right in every frame. To see it in a slower frame rate, let's reduce FPS. Now that we are sure everything works right, let's correct everything we changed. Next function is a snake updating. We pass a snake dir, a snake list, a snake it, and a snake dead boolean into it. At first, let's see how we move a snake in code and how we update a snake list. A snake list first and last element is head and tail coordinate. Every frame we make new head and insert it in the first place of the list. Position of this new head is one cell away from head in snake direction. Every frame we also remove last element of the snake list, which is the snake tail, unless a snake eats an apple in that frame. Okay, to do this, let's check if a snake eats an apple or not. If no, we remove the tail, and if yes, we just change a snake eat boolean to false. After that, we find what is the snake direction. Then, based on that, we make new head. A snake updating is done. Let's return what we changed inside this function and add this function to game loop right after a snake generating function. Because we need a snake list and a snake dir not to be empty for updating a snake function. Okay, now let's check if a snake moves. As you see, a snake can go through itself, and it's because we accept invalid direction when we were reading player inputs. Let's reject those directions as we did in snake generating function. Now we check again. And this time I can use any invalid direction to move a snake. But still, a snake can eat an apple, and it can go through walls. I will make eating apple and hitting wall features with collision function. We need to pass all our game variables and lists into this function. First thing we do in this function is to check if a snake head position is equal to apple position. If yes, we will change a snake eat to true. Add 1 to a score and reset apple pose so apple generating function can make new apple. Then for a snake collision with the wall, we check if a snake head is adjacent to wall and if a snake direction is toward the wall. If these two conditions are true, a snake will hit the wall, so we change a snake dead boolean to true. For a snake hitting itself, we check if a snake head is in the body list or not. If yes, a snake dead boolean will be true. At the end, we return what we changed inside this function. Now let's add this function to game loop after updating a snake and check if it works. It seems I did something wrong and eating part in collision doesn't work right. Let's check if a snake can hit walls. Okay, this part works correctly. The problem is here. I addressed head x coordinate instead of head element. Let's check again. As you see, a snake can hit apple and can hit wall and itself. We are done with this part. Now let's make a font to display a score on game window. You should pass font name as a string and font size you desire to this sysfont method of Pygame font class. After this, we move to draw part of the game loop. You should put font draw code before apple and a snake, so a snake and apple be drawn over font. This is how Pygame works. It draws objects into game window in order we code them. We draw font in two colors, one light red color when a snake is dead, and one dark gray when a snake is alive. To draw font into a screen, you should use render method which turns font into an image. First thing you should pass into render is the string you want to show. Second one is a boolean. If you want to have a smooth corner in text, set it as true. Last thing is color. To draw an image into a surface, you should use bleed function from Pygame surface class. This function takes in an image and a tuple, the image you want to draw and the top left coordinate as a tuple. Here I didn't pass a simple tuple, because I want text being center of the screen and this can't be done with one fixed position. As you see, I used getRect method. In Pygame, you can use this function to get properties of rectangles. I pass in a new center for text rectangle and get top left position based on that center position. This function will do the math every time text changes. Let's see the result. Here we are done with coding in Pygame. In the next part of the video, we will work on gym environment setup. In this part, we will see how gym environment works and how we can feed our code into it. We have a class that inherits from gym environment class. I named this class SnakeEnv. This class has 5 functions or methods. First one is the init method that would be called when an object is made by this class. In this function, we always have these 2 attributes. One is action space. Action space type can be box, dictionary, discrete, tuple, and so on. Here we use discrete, which makes random integer numbers that we use them as our actions. In a snake game, we have 4 types of input, and they are up, down, right, and left. We will have a number for each one of them from 0 to 3. Next attribute is observation space. In this game, we choose box type, which is similar to lists. We define lowest and highest value of box. Here they are 0 and 40. Then we define its shape, which is how many values we will put in box. And the last one is box data type. I use float32. Here data type can be integers, but I prefer float numbers because it applies to integers and may avoid feature errors. Also, using float numbers here have no influence on training speed. Next function is a step. Every frame this function is called to handle game backend and update game variables. Reset is the next function. This is used at the start point of an episode. In this game, an episode is one game round, but in other games, every episode can have fixed frames. Next function is render. When this function is called, we will display game into a screen. And when this function isn't called, we just run game in background and we will not have any visualization. Last function is close. We will use it to close the Pygame. Now let's import built-in classes and libraries that we need. First thing we bring here and put it before a snake environment class is these variables: width, height, row, column, and FPS. We should change FPS to a higher value because we don't play here. After it, we add 4 functions that we built in a snake game. First thing we add to a SnakeEnv is render mode attribute, which its default value is none, and we change its value only once we want to render the game. Here's the thing. You can make all variables in init function, but you also need to reset them in reset function for every new episode. So you can only make these variables in reset function and that would be enough. First one is done attribute and its default value is false. This is used to end episodes. Let's copy other game variables into reset function. We also need to put self dot at first of all. After it, we need to copy execution of a snake generating and apple generating functions into reset method. Here we make initial observation, one of the 5 things, and the last one of them that we pass into observation is a snake direction. Directions are a string, and we need to change them to number, and those numbers should be fixed and unique for every direction. I named this attribute numerical dir, and I will define it in for if statement for each direction. Here, observation is a list that contains 5 elements. Those are snake head, x and y coordinates, apple pose, x and y coordinates, and last one, as I said before, is numerical direction. Those 5 are integer numbers that are in range of 0 to 40. After making observation list, we need to change it to NumPy array. That's how gym environment accepts it. After it, we move to a step method and copy execution of collision, snake updating, and apple generating function into it. One thing we should have in mind is that in gym we don't have a string type input direction. Instead, we have 4 numbers as input. So we need to translate these action numbers to direction, then our function can use them. We will do them as we did it for numerical direction. Now it's time to define observation in a step method. It's similar to observation in a reset. We only need to change numerical dir to action. Then we check if a snake is dead. If yes, we set down attribute to false and end this episode. But before episode ends, we also need to define reward. For that, first we go to reset method and define variables that are related to reward. These variables are reward and score, and previous score, which is the previous frame score. Next one is distance between snakehead and apple. Here I used Hamilton distance because the snake moves in a straight path. And we also have previous frame distance. Here we use previous score and previous distance to punish or give reward to agent based on the changes he made in every frame. Next variable is valid time step to eat apple. This is equal to highest path snake should go to eat apple, and that's it, the summation of width and height of the grid and the snake size in case a snake needs to go around itself. We add 1 to this value every time a snake eats an apple. Last variable is time step past eating, and it keeps how many time step or frame is passed from eating. These two last variable will help us in punishing agent if it wastes time and avoid eating apple. Now that we are done with reward variables, let's move to a step method and calculate reward for every frame. Reward for agent contains 4 parts. First one is death punishment. If a snake dies, we give our agent negative 100 points as punishment. If a snake stays alive, it receives no reward. Next part is for eating apple. Every time a snake eats, we give it positive 10 points as reward and we update previous score. A score variable will be updated in collision function. In case a snake eats nothing in every frame, we give it no reward. Next one is reward and punishment for a snake distance from apple. At first, we update current frame distance and then compare it with previous frame distance. If a snake gets far from apple, we give it negative 1 point, and if it gets close, we give it positive 1 point. If there is no change in distance, reward will be 0. After this, we will update previous distance. Last part of reward is punishment for wasting time and not eating apple. We divide time step past eating by valid time step to eat, and negative quotient of this division will be the punishment. And at the end we need to calculate the reward, and for that we sum these 4 parts. One thing we need to do is to reset time step past eating and add 1 to valid time step to eat when a snake eats. We also need to increase time step past eating value by 1 when a snake doesn't eat apple. One of the things that is returned from step method is info, and we just define it as an empty dictionary. Now it's time to handle rendering. In a step function, we check if render mode is equal to human. We call render function. We do the same thing in reset function. We also start Pygame library here. It is faster to do it once in reset function instead of doing it every frame in render function. Don't forget to put self-dot for new variables. Now it's time to copy drawing part of the game and also controlling speed part into the render function. This part is optional. We delay game every time a snake is dead for better visualization. Last thing to do in this part of the video is to close Pygame in close method. In this part of the video, we work in Jupyter Notebook to train the agents. To open Jupyter Notebook, go to the directory that your Python code files are in. In address bar, type cmd and run command prompt in this directory. In cmd, enter Jupyter Notebook command and run it. Jupyter Notebook will be opened in a browser. This is the same directory. Make a new Python 3 file here. I changed the name of this file to snakeRL as reinforcement learning. To work with Jupyter, you should know that it works in blocks, and you can divide your code to as many blocks as you want and run them separately and in any order you want. In first block, I import OS to handle paths and directories to save and load files. Then from stable baseline tree, I import PPO model. This is the model which will do the reinforcement learning. And for the last one, I import all codes in a snake.env file we wrote in previous part of the video. Let's run it. There is no error, so we move to the next block. In this block, we define 2 passes. First one to save logs and second one to save our model and load from it. In next block, we make an object from a snake.env class and we call it env. With PPO, we make a model. Here are what we should pass in. First one is the policy we want to use. Here we use MLP policy. Second one is environment we make. Third one is verbose, which can be 0 for no output, 1 for info messages, such as device or wrappers used, 2 for debug messages. And fourth one is the path we want TensorBoard save its logs. Let's run it, and as you see, this is the data we receive when we set verbose to 1. First line says we are using CPO for computations. In next block, we will set render mode to human, and then execute learning. We should pass how many time steps or frames we want to run training. As you see, the snake is taking random actions and go through itself and die. It will take some time to learn avoid invalid directions. Here are some metrics that will help us understand how agent is learning. First one is the mean of episode length. Second one is the mean of episode reward. In a good training, you see these two increases. Third one is FPS, which is lower than what we expect. And I think it's because of other functions delaying rendering. You can have higher FPS by increasing FPS in code. Next one is the iteration, which is 1 here. Every iteration is a number of time steps, which I think it is the number we are seeing at total time steps. Time elapsed is how many seconds it takes to complete training. We are done with this info. In next block, we will call close function which close the window. After it, we execute learning with no rendering to see how fast it runs. We will do it for 5000 time steps and it starts with a high FPS. That is done after 8 seconds. In next block, we save our model and we go to the directory to see the save file. The last thing we do is load the model from that file. You should pass in file address and define env for it. I ran this model for 2 million time steps and this is the result. As you see, this model is not that good yet. You may get a better result if you run model for a longer time or change in reward and observations make better results. But as far as I searched, the snake game is a tricky game and can't be completely solved with machine learning algorithm. But feel free to try and if you had a better result, let me know in comments.